test. Okay, works perfectly, I guess. So this live session, I'm gonna solve Dr. Ahmad's quizzes, and for fall 2023 and 2024. And if we have time, I can like solve extra questions, inshallah. طيب, see this one. Bruh, I mean, it's self-explanatory, or what? How it's called? Self-explanatory. As we approach -3 from the left, this is -3. As we approach -3 from the left, the function goes to a y value of -2. Okay. -3 from the right, this is -3. As we approach it from the right, the function goes to a y value of 0. As we approach 4 from the left, 4 from the left, we approach the function from the left, y value of 2. 4 from the right, y value of 2. As x approaches to 2, this is 2. So in general, it didn't specify from the right or left. So we have to check from both. From right, it's 3. And from the left, it goes to -infinity. So left doesn't equal right, so it does not exist. So it does not exist. F at 0, there is no such value at 0, so it's undefined. Like no point here, maybe. If there is a point, we'll say like f at 0 equals 2, but there is no point on the graph, so it's undefined. F at 4, it's this closed point, so it's at 1, y equal 1. And as x approaches to -infinity, as we approach -infinity, the function goes to a y value of -1, of y equal -1. Okay, as we approach -infinity. So this is -infinity, this is positive infinity. As the function goes to -infinity, the function will approach a y value of -1. Okay, so first question is like very simple. What's the domain of the given function? You know that the domain is all of the defined values on the function. Like you can think about it as if you don't leave your finger, or if you don't leave your pen off the page, then the function is defined. So I'll start from left to right. Okay, we always start from left to right. So I'm gonna start. Okay, there's a point here. Okay, so it's defined at -3. Okay, so it's part of the domain. Then continue. It goes to positive infinity. Then at x equals 0, there is no such point to like go from positive infinity to this part. You know, like I have to raise my hand and start from here. So at x equals 0, the function is not defined. At x equals 0, it's not defined. So let's continue. Now, same thing here. Um, I have to lift my hand and go to this point, and this point is not filled. You see this circle is not, it's not filled. So it's undefined at x equal 2. So at x equal 2, it's not defined also. Let's continue, continue, continue. It's defined at x equal 4. So some students will say like it's not continuous. Okay, it's not continuous, but it's defined. It has a value at x equal 4 with the y value of 1. So it's defined. It's part of the domain. The domain, all of the points that doesn't have a y value on the function. طيب? So at x equal 4, it's part of the domain. So let's continue, 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 and we finished. So I only have 2 points where the function is not defined at. So I'm gonna exclude them from the domain. If I want to write it in like the interval notation, so negative infinity to 0, union 0 to 2, union 2 to infinity. Notice that I use parentheses, not brackets. Brackets when you want to like include them in the domain, but I want to exclude them, so I use the regular parentheses. So I want to exclude 0, 0, and I want to exclude 2. So that's the domain of the function. Let's see. Oh, let's see the answer. Yep, negative infinity to 0, 0 to 2, and 2 to infinity. For what value of x does the function has a removable discontinuity? Removable discontinuity, let me give you like an overview about removable discontinuities. Maybe I have a function like this, and at some point there is a hole, and then the function continues. So at maybe x equal a, at x equal a, I have a hole which is called a removable discontinuity. Why it's called a removable discontinuity? Because I can rewrite its domain and fill this gap, and it will be continuous. So that's why it called removable discontinuity. I can remove the discontinuity. So that's why it's called removable discontinuity. Same thing as something like this. If I have a function like this, an open circle, and I have a defined function, a defined value at this point. So this point called a, I have like fa is defined. Fa is defined. طيب. But it's not filling this hole. So it's also like a form of removable discontinuity, and I can define it as if I bring this point and put it right here to fill the gap, I will remove the discontinuity. So this is another part of, or another form of removable discontinuity. So let's say in our example, this one is jump discontinuity because like function from the left is equal to -2, and we have like a jump. The function jumps to a value of 0, so it's definitely a jump discontinuity. At x equals 0, we have infinite discontinuity. We need at least one side of the function approaches infinity to call that specific point a vertical asymptote, or an infinite discontinuity. One side is enough. Like, for example, at x equal 2, like from the right, it's not approaching infinity, but from the left, one side is enough to call x equal to a vertical asymptote. And this type of discontinuity, it's not called jump, it's called infinite discontinuity, because one of the side of the function approaches negative infinity, so we call it infinite discontinuity. So not at 2, not at 0, not at -3. Let's see at x equal 4. It's the same case that I previously showed you. We have a hole and a defined value at x equal 4 with the y value of 1. So this is definitely a form of removable discontinuity. I can remove the discontinuity by moving this value to fill this gap here. Okay, so at x equal 4. Yep, removable discontinuity at x equal 4. For what value of x does the function has a non-removable discontinuity? Non-removable discontinuity basically like all of the other discontinuities excluding removable discontinuities. So at x equal 4, it's a removable discontinuity. So any other discontinuities will be considered as non-removable at x equal 2, at x equal 0, and at x equal -3. This type of discontinuity is jump. At x equals 0 is infinite discontinuity. At x equal 2 is also infinite discontinuity. So at x equal -3, 0, and 2. -3, 0, and 2. State if any the vertical and horizontal asymptote of x, of f of x. We have vertical asymptote at x equals 0 because one of the sides of the function approaches infinity, and I said only one side is enough to call a point a vertical asymptote. So at x equals 0, there is a vertical asymptote because one of the sides are approaching infinity. And at x equal 2, the left side approaches negative infinity, so we can call x equal to a vertical asymptote. So at x equals 0 and x equal 2. The others are not considered as vertical asymptotes. For horizontal asymptotes, we need to take the limit as x approaches to infinity and negative infinity. So when x approaches negative infinity, as we approach negative infinity, the function goes to a y value of -1. Like this part of the function will never exceed -1 because there is a horizontal asymptote at x equal, or sorry, at y equal -1. So this part of the function will never exceed y equal 1. Okay. Yep. I don't see other horizontal asymptotes. Maybe at y equal 4, I'm not sure. Let's see. No, not y equal 4 is not an horizontal asymptote. Just at y equal -1, as I told you, this part will never exceed -1. And for vertical asymptotes, only 0 and 2, because one of the sides of the function approaches infinity. So this is for the first page. Let's go to the second. Use algebraic methods to evaluate its limit. Let's start cooking. Okay. I mean, for this limit, let's try to plug in the 0 first. Always try to plug in the number first. So pi over 2 times 0 is 0, plus 2 ln 0 plus 1 over 0 plus 1, cosine of 0 plus 2 ln 1 over 1. Cosine of 0 is 1, plus 2 times ln 1. Ln 1 is 0, I guess. Yep, 0. Ln 1 is 0. So 0 over 1. So 1 plus 0. 1 plus 0 over 1 is 1 over 1, and 1 over 1 is 1. So just plug in the number and you should be fine. Okay, next question. Always plug in the number. Okay, let's plug in the number. -2 times 1 over 1 minus 1 with an absolute value. طيب, So get -2 over 0. So whenever we have a number, a constant over 0, maybe the limit value is positive infinity, negative infinity, or does not exist. For this limit is one-sided limit, so it wouldn't be does not exist because it's one-sided limit. So it's either positive infinity or negative infinity. Now, how we should know? We will solve the limit basically. So let's start by rewriting the absolute value as x approaches to 1 from the right. طيب 1 minus x is basically contain two functions, negative 1 minus x and 1 minus x with a positive. طيب this one would be when x is, let's say 1 minus 1, so yeah 1, when x is less than 1, and we'll choose this part of this function when x is greater than or equal to 1. Okay, so basically what I did is I rewrited this absolute value function as two functions. Now when rewriting absolute value functions, we just multiply by the sign of the absolute value function. So in this case it's positive, so positive x, and for the bottom function we just flip the sign, so negative x. Okay, and to know the domain of this function and this function, you just basically equal the inner function with 0, so you get x equals 0. So when x is greater than or equal to 0, we'll use the positive x function, and when x is less than 0, we'll use the negative x function. Now similarly, in this case, 1 minus x is equal to, we have to equal the inner function with 0, so 1 minus x, move the x to the other side, so x equal 1. So at 1 the function will change, so at 1 the functions will change. طيب. Now for the top function you have to multiply by the sign of the x, so x is negative, so I have to multiply by the sign of the x for the top function, and for the bottom function I just flip the sign, so positive 1 minus x. Okay, so that's what I did basically. طيب. And for the domain, I'm not sure, let me check. Well, I forgot how we got them, but I remember it's x less than 1 and x is greater than 1. But let me check. Yep, x minus a, so negative x plus a, negative x plus a. So negative x plus a is greater than or equal to 0. So we need to move the a. In this case, a is equal to 1, right? So we basically move the 1 to the other side, so negative x is greater than or equal to negative 1. Now we have to divide by negative in both sides, so x, when dividing by negative, the sign will flip, so x is less than or equal to 1. So that's what I did. X is less than 1. You don't need to write the equal sign, just put it wherever you want, maybe here and remove it from here, it doesn't matter. طيب. And if this is x less than 1, then the bottom will definitely be x is greater than 1. Okay, so this is how you rewrite the absolute function. We spent a lot of time on it. Now, x is approaching 1 from the right. If I draw the number line like this, and this is the 1, I'm approaching 1 from the right. So the values would be 2, 3, 4. All of these numbers are greater than 1, right? So I will choose this one, this function, the bottom function, and I'm gonna substitute it instead of the absolute value function. Okay, so instead of writing absolute 1 minus x, I'm gonna substitute it with 1 minus x because I'm approaching x, I'm approaching 1 from the right, and 1 from the right means x is greater than or equal to 1. Okay, and for the numerator, it's negative 2x. Okay, now if I substitute negative 2 times 1 over 1 minus 1 would give me negative 2 over 0. Like, it's similar to this. I know it's silly, but um, it's not how we should done it like this. We should not substitute 1. We should substitute 1 from the right. So instead of writing just 1, we should substitute 1 from the right. Okay, so 1 from the right. So negative 2 times 1 from the right is negative 2. You can think about negative 2 times 1. But for the denominator, 1 minus 1 from the right. So let's draw the number line again. This is 1. And 1 from the right, maybe 1.01. So 1.01 is greater than 1. So I'm dividing, not dividing, I'm subtracting the like lower value from a larger value. So I will get negative 0.01. It doesn't matter the value of the subtraction. I just want the sign of the subtraction. Okay, so I know that it's negative in the denominator, so it would be negative some number, negative c. Let's call it negative c, or yeah, negative c. Now the negative will cancel, so we will get 2 over c. Okay, now 2 over c means positive infinity. Okay, so let's check it. صح ولا جبت العيد؟ Okay, this guy like missed it. Negative 2x over absolute value 1 minus x calc 1.001. Oh, negative infinity. What? Whoa. Just negative. X is larger than 1. And we had to use this. 1 minus x over minus x. 1 minus 1 from the right. Wait. So it's positive when x is greater than 1, and it's negative when x is less than 1. Okay. So negative 2 times 1 is negative 2. Oh, okay. So negative 2 over 1 minus a larger number would give me a negative uh, number, as I said. So I think we shouldn't be canceling the negatives. So whenever you get a negative number out of this process, or maybe a positive number, you know that it's negative infinity. I think so. I think so. Yeah, I think so. Like, don't bother yourself with the numerator, okay? Just look for the denominator. If it's negative, then the answer would be negative infinity. If it's positive, then the answer would be positive infinity. Don't cancel the negatives out. That's the mistake that I've done. Yep, yep. So, yeah, that's for this question. Next question. This one is easy. You just have to plug in the limit into the angle of the tan, 0 from the left, of 1 over x squared. Now, 1 over x squared, you have to know the graph of it. 1 over x squared graph would look something like this. Okay, because 1 over x looks like this, but because of the square, this is the graph of 1 over x. But because of the square, the function on the bottom will get positive, so it will be reflected on the x-axis. Okay, so yeah, I mean, you just have to memorize the 1 over x, and whenever you see a even power on the x, just flip it around the x-axis. So anyways, this is the graph of 1 over x squared. Now we're asked to approach it from zero from the right. So this is 0. We'll approach 0 from the left, sorry. From the left, the function goes to positive infinity. So this limit equals to positive infinity. How did I knew that? From the graph. As we approach 0 from the left of this function, this is the graph of this function. As we approach 0 from the left, the function goes to positive infinity. So that's how I knew that the value of it is positive infinity. Now, for tan inverse, you also need to know the graph of tan inverse. Pi over 2, negative pi over 2, and the graph looks something like this. Okay, so x approaches positive infinity. So this is positive infinity, this is negative infinity. So positive infinity, it approaches pi over 2. So the answer would be pi over 2. Okay. This one is definitely wrong. Pi over 2 or negative pi over 2, this is wrong. The answer is pi over 2, positive pi over 2. Let's see this question. Oh. Limit x 0. Let's take cosine x as a common factor. So we're left with 1 minus cosine square x, right? Like if I redistribute this, I'll get cosine x minus cosine cube, right? So I took one cosine out, and in the denominator it's simply sine square x. And I can rewrite the sine square. Remember the trigonometric identities? Sine square x plus cosine square x equal 1. Now move the cosine to the other side. You'll get sine square x is equal to 1 minus cosine square x. Now I have sine square x, so I need to replace it with 1 minus cosine square x. It's obvious why I did that, right? 1 minus cosine square x. Now I can cancel out the 1 minus cosine square x. So I'm left with limit x0 cosine x. Now plug in the 0. Cosine of 0 is equal to 1. Right? Yep. Simple and easy. Third page. Consider the function defined by find all intervals of continuity of f of x. Like, so basically he's asking for the domain. For part A, he's asking for the domain. Continuity is the same as finding the domain. So what's the domain of this function? F of x equal x squared plus x minus 12 over x squared plus 2x minus 8. We only have the denominator thing. It doesn't have to equal to 0, or it must be Brahma. It mustn't equal 0, maybe. Okay, never mind. X squared plus 2x minus 8 doesn't equal to 0. Now factor this out. You'll get, I'll use calculator, mod A2, no, mod 922, 1, write the coefficients, activate x minus 2, and x plus 4 equals 0. Now, doesn't equal to 0. Now remember the zero property, zero product property. X minus 2 doesn't equal to 0, and x plus 4 doesn't equal to 0. Plus 2 plus 2, x doesn't equal to 2, and minus 4 minus 4, x doesn't equal to negative 4. So the intervals of continuity of f of x would be all of real numbers except negative 4 and 2. I will write it in the interval notation. Negative infinity to negative 4, union negative 4 to 2, union 2 to infinity. Okay. For question B, or part B, classify all discontinuities as removable or non-removable. If possible, extend the given function to a function continuous over larger domain. So yeah, this is the answer for part A. Part B is asking for classifying the types of discontinuity, if it's removable or non-removable. Now I'll give you a trick. Let's factor the numerator first. 1, 1, negative 12, minus a 3 plus 4, x minus 3, x plus 4, and the denominator was x minus 2, and x plus 4, right? Now, this is f of x. I haven't changed anything. Just I have just factored it out, factored the numerator and the denominator using the calculator. Now, you can see that I can cancel x plus 4 out from top and bottom. So whenever you cancel something, it's called a removable discontinuity at this point. So in this case, x is equal to negative 4. So at x equal negative 4, there is a hole or non-removable discontinuity. Okay? How did I knew that? Because I was able to cancel something from the numerator and the denominator. If I could cancel a problem in the domain, then it's a removable discontinuity. Oh, sorry. Then it's a removable discontinuity, right? As I showed you in the graph, I can cancel the problem if I define that point at that hole. Okay, so the same thing here, same thing applies here algebraically. If I cancel the problem from the numerator and the denominator, then I can tell that it's a hole and its type is removable discontinuity at x equal negative 4. But x minus 2, I can't cancel it with x minus 3. There is no such x minus 2 in the numerator. So I can't cancel this problem here. I can't cancel x minus 2. So I can conclude that at x equal 2, it's a non-removable discontinuity. And if you want to be more specific, it's an infinite discontinuity. Okay? How did I knew that it's infinite discontinuity? Because it's on the denominator. So any problem in the denominator that can be resolved, it's called infinite discontinuity. Any problem in the denominator that can be solved, it's called a hole or a removable discontinuity. So I can solve this problem, x plus 4, okay, and cancel it with the numerator. But for x minus 2, I couldn't. So that's why it's called non-removable discontinuity, aka infinite discontinuity. Okay, so if possible, extend the domain. I mean, if it's possible, aka if it's removable discontinuity, extend it. So we'll extend it by defining it as piecewise function. So I'll write the normal f of x minus 12 over x squared plus 2x minus 8. This function applies when x is not equal to negative 4, and when x equals negative 4, I want the function to equal, let's see, equal what? Oh, let's solve the limit first. Limit as x approaches to negative 4, x minus a 3, and x plus 4, x plus 4, x minus 2. These will cancel out. Limit as x approaches to negative 4, x minus 3, x minus 2. Plug in 4, negative 4 minus a 3, negative 4 minus 2, negative 7 over negative 6, so 7 over 6. So when x equal negative -4, I want the value of the function to equal 7 over 6. Right? يا رب ما أكون غلطان. لا والله half. والله. Oh, he's wrong. شوف. He's wrong. Um, bruh. But he did the same thing. He just like rewrite it as piecewise function. When x doesn't equal -4, we use this function. And when x equal -4, I want the function value to be the solution of the limit. So the solution of the limit as x approaches -4 is 7 over 6. So when x equal -4, I want the value of the function to equal 7 over 6. Okay? So that's how you solve question 3. It's simple. Last two questions. I mean, Dr. Imad's quizzes, I heard that they're harder than other doctors' quizzes, but so far so good. Like they're pretty simple, I guess. Given the function defined by f of x, find all asymptotes, vertical, horizontal slants for the function. Okay, for vertical asymptotes, basically we have to find the domain of the function. For horizontal asymptotes, we have to take the limit as x approaches to positive and negative infinity of f of x. And for slant asymptotes, we have to do long division. Wait, division with an S, right? Okay, but like the power of the numerator must be greater than the power of the denominator by only 1, because if it's greater than the power of the denominator by 2, then we can't apply this rule. Okay, so let's start by vertical asymptotes. Let's find the domain of f of x. F of x equal x squared plus 2x plus 1 over x. Now it's obviously x can't equal to 0. The denominator must not equal to 0. And we have another issue with the radical on the numerator. The radicand should be greater than or equal to 0. Okay, now let's solve this. Factor first. Mod A 2, mod 9 2 2 1 2 1 x plus 1 and x minus 1, right? Yep. Wait. X minus 1 square, sorry. X minus 1 square. Let's move it on. X minus 1 square. Now, let's take the square root of both sides. The square root will cancel with the square, so x minus 1 greater than or equal to 0, plus 1, plus 1, plus 1. This will cancel. X is greater than 1. So, x can't equal to 0, and x can't equal to 1, right? can equal to 1. So 1 is not a vertical asymptote. 0 is just the vertical asymptote. Okay? So x equals 0 is a vertical asymptote. Okay. For horizontal asymptote, we have to take the limit as x approaches to positive infinity first. X squared plus 2x plus 1 over x. Limit x infinity. Now take x squared as a common factor. You're left with 1 plus 2 over x plus 1 over x squared, right? Over x. Then limit as x approaches to positive infinity. And you can split them to radical x squared times radical 1 plus 2 over x plus 1 over x squared. And radical x squared is simply absolute value of x times, when x approaches to infinity, these will equal to 0 because they are constant over a variable, and the variable is getting to a huge or significantly huge number. So when you divide a number by a huge number, you'll get 0. So this will simplify to 1 plus 0 plus 0, which is radical of 1, which is 1. So I just made some simplification here over x. Now you have to like rewrite the absolute x as I showed you before. Just multiply by the sign of the x and switch it for the bottom. You use the top one when x is greater than or equal to 0, and the bottom one when x is less than 0. Okay, now in this case x approaches to positive infinity, so it's definitely greater than or equal to 0, so we're going with the top function. Limit x infinity. Instead of absolute x, I'll write x over x. X over x is 1, and whenever there is a limit of a constant, it's just the constant. So as x approaches to infinity, it equals to 1. طيب. So we got one of the horizontal asymptotes by approaching x to positive infinity. Now let's repeat the same process, but with x approaching negative infinity. Limit x negative infinity. X squared plus 2x plus 1 over x. Limit x negative infinity. First, let's take x squared as a common factor. Then we're left with 1 plus 2 over x plus 1 over x squared over x. As I told you, we can split these up. So radical x squared times 1 plus 2 over x plus 1 over x squared. This will simplify to not radical. I mean, I'm mixing things up. Absolute of x times, I told you, as x approaches to negative infinity this time, it doesn't matter. 2 over a negatively large number will give you also 0. So this will simplify to 0 plus 0. So radical of 1 is 1. So limit as x approaches to negative infinity of absolute value of x times 1 over x. Now let's rewrite the absolute value function. Positive x and negative x. Positive x when x is greater than or equal to 0, and negative x when x is less than 0. Now in this case x approaches negative infinity, so it's less than 0, so So we're going with the lower function. So negative x over x. X over x is 1, but we have a negative. So negative 1. And whenever we have a limit of a constant, it's just simply the constant. So as we approach positive infinity, we got 1. And as we approach negative infinity, we got negative 1. So these are my horizontal asymptotes of this function, 1 and negative 1. But you have to write like an equation for the horizontal asymptote, not just like write 1 and negative 1. You'll get 0, I guess, or partial credit for it. So you have to write y equal 1 and y equal negative 1. Or you can say y equal positive negative 1. It's fine also. Okay? So you get the full credit. Slant asymptotes, well, I don't see a slant asymptote because the power of the numerator is the same as the power of the denominator. Because if you took x squared as a common factor under the square root, so the square root of x squared is absolute of x. And when you simplify this, you'll get either negative x or x. And it's the same power as the denominator. So there is no slant asymptotes. In fact, there is only horizontal and vertical asymptotes. And to be sure, like to confirm your words, horizontal asymptotes and slant asymptotes doesn't come with each other. Like if you got horizontal asymptotes, then there is no slant asymptotes. If you got slant asymptotes, then there is no horizontal asymptote. So yeah, there is no slant asymptotes, only vertical and horizontal. Vertical asymptotes, x doesn't equal to 0, and horizontal asymptotes, y doesn't equal plus or minus 1. Yep, true. Find the value of k that makes f of x continuous. Easy. Easy peasy. So it's mentioned that f of x is continuous. And whenever a function is continuous, the limit as x approaches a of f of x from the right will equal the limit as x approaches to a from the left of f of x, and these should equal to f of a. Okay, so we have here f of a, which is k, so aka f of a, and f of a, we have the number 2, so we say f of 2 instead of f of a. And this one is the limit. It's not from the right or left, it's in general from both sides. Okay, so since the function is continuous on all x values, so I can equal the limit as x approaches to 2 of 2x plus 5 minus x plus 7 over x minus 2 with k. So basically what I did is I equaled the limit with f of 2. Okay, now to find k, you just simply have to solve this limit. So let's solve this limit real quick. If you plug in 2, you'll get 0 over 0. So you need to manipulate it in such a way you can like plug in the 2 without any problems. So let's multiply by the conjugate of the numerator. 2x plus 5 plus, just switch the sign between the radicals, x plus 7, and multiply the numerator and the denominator. Don't forget to multiply the denominator also. Okay. Now the numerator will be simplified to a square minus b square. Okay. Where is a and where is b? This is a and this is b. So a is 2x plus 5 square minus b is root x plus 7 square. So the square will cancel the radical. So 2x plus 5 minus, put them in parentheses, please. The square will cancel the radical, x plus 7. Then distribute the negative over the parentheses. So negative x, negative 7. Now combine like terms. 2x minus x is x minus 2. X minus 2. So the numerator will be simplified to x minus 2. Limit as x approaches to 2, x minus 2. And for the denominator, don't touch it. Just write it as it is. 2x plus 5 plus x plus 7. Now you can clearly see that we can cancel x minus 2 from top and bottom. Now you can plug into without any problems. You should be able to plug into without any problems, inshallah. So 1 over 2 times 2 plus 5 plus 2 plus 7. Let's put this into the calculator and see. 1 over 2 times 2, which is 4, plus 5, plus 2 plus 7, 1 over 6. So the value of this limit is 1 over 6, 1 over 6, and it equals to k. So that's the answer. Yep, 1 over 6. That's the end of quiz 1. Let's see if we have another quiz. Nope, this is quiz 2. So let's go to fall 24. Oh, sheesh. I mean, this is not... This is quiz 3, bruh. Yeah, so derivatives and stuff. Midterm exam? What? This is a midterm exam, bro. Quiz 3. This is quiz 2. Oh my god. Quiz 3. So we don't have quiz 1 full 24. Okay, it's fine. Let's solve questions from my drive. Previous quizzes, quiz 1. Let's download it. Let's see. Okay. Quiz 1A. Evaluate the limits. If limit does not exist, explain why it does not exist. Okay. Easy peasy. Factor top and bottom and you should be fine. Or just plug in the number first. Let's plug in the number. 3x squared minus x minus 2 over 2x Okay, we got a math error. So it's like probably 0/0. And limit x1. Now, if you want to solve this by your calculator and you don't know how to factor this kind of expression, because it's multiplied by 3, the x squared is multiplied by 3, so you have to factor the 3 out first. So x squared minus 1/3x minus 2/3, right? Yep. So if you distribute the 3, you'll get this numerator. So 3x squared. Yep. And same for the denominator. You have to factor the 2 out. X squared plus 1/2x minus 3/2. Okay. Then put this into your calculator. Okay. To be in the safe side. 3, 2. -1/3, -2/3, x minus 1, and x plus 2/3 for the denominator. 1/1/2 -3/2 x plus 1 x plus 2/3, wait, 3/2. Let me check the numerator real quick, because this is weird. X minus 1. Yeah, x minus 1. X minus 1. X plus 3/2. The numerator. 1 -1/3 -2/3 x minus 1 and x plus 3/2. Okay. So yeah. So you can cancel out the x minus 1 from the numerator and the denominator, and you're left with 3, 2, x plus 2/3 close x plus 3/2. If you don't like it to write fractions, you can distribute the 3. Maybe it's better. Let's try this out. So distribute, it will be 3x plus 2 over 2x plus 3. Now plug in the 1. 3 times 1 plus 2 over 2 times 1 plus 3. 3, 5, 5, 1. Yep. You see? Yeah. Next question. Right. Okay. Easy peasy. Plug in the number, you'll get 0/0. Okay. Now, I guess you have to multiply by the conjugates because there is a radical. Oh, the variable is y. In the quiz, I guess you'll lose some marks if you write x instead of y. So 4 minus y 2 minus radical y multiplied by the conjugate, top and bottom, by 2 plus radical y, 2 plus radical y. Now for the denominator, it will be simplified to a square minus b square. Where is a and where is b? This is a, this is b. So 2 square minus square. 4 minus the radical will cancel the square, or the square will cancel the radical, so we're left with 4 minus y. And for the numerator, don't touch it, leave it as it is. Limit y 4 minus y times 2 plus root y over 4 minus y. So it's clearly, you can clearly say we can cancel 4 minus y from top and bottom, and you should be able to plug in your number and it should be fine. 2 plus y, 2 plus 4, 2 plus 2, which is 4. Just check. Yep. We don't need hint, bruh. We're experts, right? Nope, we're not experts. Plug in the number, you'll get 0 over 0. So limit as x approaches to -2 of 2 cubed plus 8, plus 8, 2 plus 2. Now factor the numerator. I've already shown you how to factor it. When you have cube plus cube, this can be written as 2 cube. You know that, right? 2 cube is the same as 8. So it's 2 cube plus 2 cube, t cube plus 2 cube. So whenever you have a cube plus b cube, the rule says a plus b, a square, square the a, switch the sign, multiply a with b, and plus b square, square b. So if you apply this on our example, you'll get 2 plus t plus 2 multiplied by t square plus, switch the sign, 2t plus 4, right? So t plus 2, t square minus 2t plus 4, and the denominator t plus 2. Now we can clearly say that we can cancel t plus 2, t plus 2. This will give me a simple polynomial. T square minus 2t plus 4, plug in the -2, 2 times -2 plus 4, 4 minus 4 plus 4, so 4 plus 4 plus 4, 8, 12. Yep. Evaluate. This one though, you can solve it like directly, but I think in the midterms or the finals, they don't accept like the way the students do. They say 3 over 4 and that's it. they don't make a whole question for the student to say 3 over 4 and that's it. You have to justify your answer. So how did you get 3 over 4? You can't just simply say 3 over 4 and that's it. Okay? So we have to solve it algebraically and show the steps, all of the steps. Okay? So limit as theta approaches 0, sine 3 theta over 4 theta, or theta. Some people call it theta, doesn't matter. First, if you plug in 0, you'll get 0 over 0. So multiply the top and bottom by 3. So we'll match the angle. You see, the angle is 3 theta. So I want this angle to be multiplied by 3, and the 4 will get rid of it, like outside the limit. I hope you got the idea. Limit theta 0 sine or 3 sine 3 theta over 4 times 3 theta. Okay? Now you can split the fractions to make it easier for you. So I can say 3 over 4 times sine 3 theta over 3 theta. Now you can distribute the limits. So limit as theta approaches to 0 of 3 over 4 times limit as theta approaches 0 of sine 3 theta over 3 theta. Now for this rule to be applied, the angle should match the denominator. It already matches, but I guess in the midterms you have to do additional step, which is take u as 3 theta. Okay, so as theta approaches 0, plug in 0 here, so 3 times 0, u also approaches 0. So you have to rewrite the limit in terms of u to apply the rule times limit as u approaches to 0 sine u over u. Now you can apply it. So limits as theta approaches to 0 to a constant, it's just simply the constant, 3 over 4, times limit as u approaches to 0 of sine u over u, it's 1. 3 over 4 times 1 is 3 over 4. That's how you solve it algebraically. Not just like say 3 over 4 and yeah. I think you'll get partial credit for it. You'll get only the mark or the point for the answer. But for the steps, you'll get 0. Okay, so be careful. Let's check our answer. Of course, it's 3 over 4. Yep. So he did 3 over 4. And sine, he basically multiplied by 3 over 3 as I did. And yeah, he didn't like took u equal 3 theta. Okay, so you could do that also, but he didn't. Okay, no problem. Let's see this question. It looks interesting because it like contain trig functions. Let's see. Limit x0 6x squared cotan x cosecant 2x. If you go ahead and plug in 0, let's rewrite it first because I can't plug in 0 in the calculator. I don't have cotan or cosecant. So cotan is cosine x over sine x, right? Times cosecant is 1 over sine of 2x. Let's go ahead and plug in this into our calculator. Okay. 6x squared cosine x sine x calc 0. Yep, math error. So we have to solve it algebraically and find a way to substitute 0 without having any issues. So let's see. I mean, if I multiply the top and bottom by x squared by x squared, I should get limit as x approaches to 0, 6x squared x cosine x over sine x times x over sine 2x, right? And I will multiply the second one by 2 over 2 to match the angle. You'll get limit as x approaches to 0 of 6x squared x cosine x over sine x times 2x over sine 2x. I'm not gonna do the use sub because apparently the instructor didn't do it. Okay. So 6 times 0. I'm just substituting 0 because I don't have issues right now. 6 0 squared times, I mean the answer would be 0 because this one is equal to 0 and it's multiplied by this, so it's equal to 0, but we'll just solve it. So x over sine x will give me 1 times cosine 0 is 1 minus sine 2x, 2x over sine 2x would give me 1, or sorry, this is not a minus, this times, okay? So 6 0 squared 1 times 1, which is 6 0 squared times 1, which is 0. Okay. Oh, really? Bro. Oh my god. Oh, wait. Sorry. I said let's multiply top and bottom by x squared, but I haven't multiplied the denominator by x squared, so that's why I got it wrong. Okay. So sorry, I forgot to multiply the numerator by x squared. So there should be x squared somewhere here. x square. So x square will cancel with the x square. Okay, right? Yep, x square will cancel. And I mean, let's solve it again because limit as x approaches to 0, 6x squared. Cosine, we can rewrite it as cosine x over sine x times 1 over sine 2x. Now I said let's multiply the top and bottom by x squared, but we already have x squared. So why to multiply the top and bottom by x squared when you already have x squared? But like you can distribute the x squared over this fraction and this fraction. So every fraction got 1x squared. So every fraction get 1x squared. So 6 times x cosine x over sine x times x over sine 2x. Now this one you should multiply 2 by 2. So limit x 0, 6 x over sine x times cosine x times 2x over 2 sine 2x. So we have 2 over here. So 6 over 2 times x over sine x times cosine x times 2x over sine 2x. This one will result to 3. And this one is 1. This one, if you substitute 0, you'll get 1. And this one will give you 1. So 3 times 1 times 1 times 1 times 1 will give you 3. So that's how you solve it. As the instructor said, 3. Yep. So sorry for the first explanation. It was like pretty dumb. Oh, I solved this question. Right. Okay, limit as x approaches to 0. If you go ahead and plug in 0, you get 0 over 0. Now we have absolute value. So we have to rewrite the absolute value as two functions, positive x and negative x. Positive x when x is greater than or equal to 0, and negative x when x is less than 0. طيب. Now it didn't specify whether we need it from the right or left, but at x equals 0, the function changes. So maybe the value of the function changes also, or the value of the limit will change since the functions will change at x equals 0. So we have to check from both sides. So I'm gonna evaluate the limit from the right of 2 over x minus 2 over absolute value of x, and from the left, limit as x approaches to 0 from the left, 2 over x minus 2 over absolute of x. From the right, this is the number line. This is 0. From the right, like I have values of 1, 2, all of these values are greater than or equal to 0. So I'm going with the top function, which is positive x. So I'm gonna substitute instead of absolute of x, I'm gonna substitute x. Now 2 over x minus 2 over x, like you have the same quantity, so you'll get 0, and any limit to any constant will give you the same constant. So from the right, I have a value of 0. Let's see from the left, limit as x approaches to 0 from the left, 2 over x minus 2 over absolute of x. I'm approaching 0 from the left, So 0 from the left, let's draw a number line. 0 from the left, like values of -2, -1. So all these values are less than 0. So I'm going with the bottom function, which is -x. Now I have to, bruh, I have to make them have the same denominator. So I'm gonna multiply by -1 on top and bottom. So I'll get limit x0 left -2 -x minus 2 over -x. So I can combine them into one fraction. Limit x0 left -2 minus 2 over -x, which is -4 over -x, which is 4 over x, which is 4 over 0 if you plug in 0. Now, we're approaching, like when we got a number over 0, it's either positive infinity or negative infinity or does not exist. But since it's like a one-side limit, so it couldn't be does not exist. So it's either positive infinity or negative infinity. Now, how do you know if it's positive infinity or negative infinity? Let's substitute like 0 from the left. This is the number line again. 0 from the left. Values of -2, -1, -0.01. So these are negative numbers, okay? So -4 over, oh, sorry. Let's start from here, 4 over x. 4 over negative numbers, like, for example, -0.01. Anything like on the left-hand side of the 0 are negative numbers. So 4 over negative number will give me negative. I don't care about the value of the division process, but I know for sure it's negative. Now, positive infinity or negative infinity, we know that it's negative, so it's negative infinity. So as we approach 0 from the left, I'm getting a value of negative infinity, and as we approach 0 from the right, I'm getting a value of 0. So the limit from the right doesn't equal the limit from the left, so it does not exist. The limit as x approaches 0 of 2 over x minus 2 over absolute value of x does not exist. Okay. Next question. Use Squeeze theorem. Oh, nice. Squeeze theorem, like that. So basically in Squeeze theorem, you have to look for function that you can put in or restrict its domain. So for example, x cubed, you can't restrict its domain, but for cosine number over x, you can restrict it between -1 and 1, right? Cosine 2 over x. Now, if the cosine is squared, then it's not -1. It won't start from -1. It will start from 0, and it will end on 1. But it's not squared, so from -1 to 1. Okay. Now I have to make the function in the middle look like this, look similar to the limit function, or limit question, or limit problem. So I need x cubed, so I'll multiply all of this by x cubed, so get negative x cubed less than or equal to x cubed cosine. So I'm basically distributing x cubed. Now limit, let's distribute the limit as x approaches to 0 from the left, distribute it on all three functions. So limit as x approaches to 0 from the left of negative x cubed is less than or equal limit as x approaches to 0 from the left x cubed cosine 2 over x less than or equal limit x approaches to 0 from the left x cubed. Now if you solve this limit, you'll get negative 0 cube, which is 0. Limit x 0 left x cube cosine 2 over x. And if you evaluate this limit, just plug in 0, 0 cubed is 0. So this limit is between 0 and 0. So the value of this limit should equal to 0. So it should equal to 0. Now you have to write this statement or this sentence by using the squeeze theorem limit as x approaches to 0 from the left of x cubed cosine 2 over x is equal to 0. You have to write this. If you don't, I mean, you'll lose credit. Some credit. Yeah. Let's see. Yep. Oh. Yeah, it's equal to 0. He like limited the cosine function between negative and 1 and 1 and multiplied by x cubed and then took the limit of all three, and by using the squeeze theorem, limit from the left is equal to 0. So that's how you solve the question, as I did. Next question. I think it's the last question. No, not the last. Use intermediate value theorem to show that. Oh, this one we'll skip it because we haven't took it yet. So I'm gonna skip question 7 because it's talking about intermediate value theorem, which is a theorem that we haven't took yet. Okay, let's go to question 8 and solve it. Find values of a, b, okay, such that the function is continuous. Since we know that the function is continuous, we can say that the limit as x approaches to a from the left of f of x equals the limit from the right of f of x equal f of a. So basically we can equal all three. Literally we can equal all three. So let's try by equaling stuff. Limit as x approaches to negative 1 from the left of ax minus b equal limit as x approaches to negative 1 from the right of 2x squared plus 3ax plus b. Okay? Okay. Now, this one is hard, so let's try equaling the first and third one, so we can get one value of like b, value of b. Okay, so limit as x approaches to 0 from the left. Oh no, wait, sorry. Let's see. We can't equal the first with the third because the numbers are different. We can equal the second with the third. Okay, so yeah, let's do it. Let's do it. Yeah, let's do it. 1 from the left, 2x squared plus 3ax plus b equal 4. Okay? Now, let's substitute 1. So 2, 1 square plus 3a1 plus b equal 4. So 1 square is 1, times 2 is 2, so 2 plus 3 times 1 is 1, so 3a plus b equal 4. Now move b to the other side and 4 to the other side, so... Oh no, wait. Yeah, fair enough. Fair enough. Switch the sides. Negative b is equal to 2 minus 4 is negative 2, so 3a minus 2 divided by negative 1. So b is equal to 2 minus 3a. Okay? So this is the value of b. It's 2 minus 3a. Now I can substitute, instead of b, I can substitute 2 minus 3a. So I can substitute instead of b, 2 minus 3a, and here also. So let's do this. Limit as x approaches to negative 1 from the left, ax minus 2 minus 3a. Put it in parentheses, please. Limit x negative 1 from the right, 2x squared plus 3a plus 2 minus 3a. Okay? You don't have to put it in parentheses because it's plus. But for this you should. Okay? Now combine like terms if you have, or simplify. Limit x negative 1 from the left, ax minus 2 plus 3a equal limit x negative 1 from the right, 3a, positive 3a and negative 3a will cancel out, so we're left with 2x squared plus 2. Now substitute 1, so substitute negative 1, a times negative 1 minus 2 plus 3 times negative 1. Oh no, wait. It's an a, so 3a, sorry. A times negative 1 minus 2 plus 3a, okay, correct. 2 negative 1 square plus 2, so it's negative a minus 2 plus 3a equal 2 plus 2, which is 4, so 3a minus a, it's 2a minus 2 equal 4, plus 2 plus 2, 2a equals 6, divide by 2, divide by 2, so a is equal to 3. Now you got the value of a. If you want to get the value of b, just simply plug in a here. So 2 minus 3 times 3, 2 minus 6. Okay. 2 minus negative 4. Okay. So a is equal to 3 and b is equal to negative 4. Yo, what? Bruh. Did something wrong? 2x squared, 2 squared, 2 plus 3, okay, 3a plus b equal 4, minus 4, so it's minus 2, so it's minus 2, 3a minus 2 equal negative b. divided by negative, so b is equal to 2 minus 3a. Okay, now substitute b here. Ax minus 2 minus 3a, 2 okay, plus 3a. A x minus 3 minus 2 minus 3a, okay, minus 2a plus 3a, 2x squared plus 3a plus 2 minus 3a plus 3a minus 3. Okay, sorry. Remove this. 2x squared plus 3ax. I forgot the x, so that's why I cancelled 3a with negative 3a. But it shouldn't be cancelled because there's an x here. I forgot to write it down, so that's why. Plus b is equal to 2 minus 3a. So 2 minus 3a. Substitute the negative or simplify. Ax, simplify first. Minus 2 plus 3a equal limit x negative 1 plus 2x squared plus 3ax plus 3a. Then substitute the negative 1. So it's negative a minus 2 plus 3a equal 2 plus, or no, minus 3a plus 2 minus 3a. Yep. So 2a minus 2 equal minus 3 minus 3a, and 2 plus 2 is 4 minus 6a plus 6a plus 6a, tuck 8a minus 2 is equal to 4 plus 2 plus 2, so 8a equals 6, divide by 8, divide by 8, so a is equal to, divide by 2, you would get, I have a calculator, 3 over 4. So if you want to get the b, just simply substitute here 3 over 4. So 2 minus 3, 3 over 4. So b is negative 1 over 4. Yep. And a is 3 over 4. Yep, 3 over 4. And b is negative 1 over 4. Okay, that's nice. Okay. That's for quiz A. We have like till R, all the way till R. Sheesh. We solved this one, right? We already solved this one, so let's delete it. We solved these two, so let's go to B. Let me eat bro. والله أنا ما أكلت في اليوم، طول اليوم ما أكلت شيء literally، فحاكل شوي بعدين أرجع. Yeah. Back. Factor, and that's it. You'll be able to factor t plus 1 and cancel it from numerator and denominator, and you'll be fine. T plus 1. T plus 1. This should be cancelled. Okay? So, if you go ahead and plug in 0 over 0, okay? Limit T. Oh my. Let's like lower the microphone level a little bit. Negative 1. Then factor the numerator. Menu 2, 2, 1, 3, 2. Yep. T plus 1. And T plus 2. 1. Sorry, 1. Negative 1. Negative 2. X minus 2. And obviously 2 plus 1. T plus 1. This one should be T minus 2 and T plus 1. So we can cancel T plus 1, as I told you before. And then you're left with T plus 2 and T minus 2. Plug in the negative 1 plus 2, negative 1 minus 2, 1 over negative 3, so negative 1 over 3. Negative 1 over 3. Yeah. Yep. Conjugate. If you go ahead and plug in negative 2, you get 0 over 0. So why not try to multiply by the conjugate and see what you will get? Multiply by the conjugate, x squared plus 5 plus 3, x squared plus 5 plus 3. For the denominator, it will be simplified to a square minus b square, b square. Where is a and where is b? This is a, this is b. So x square plus 5 square minus 3 square. The square will cancel the radical, so x square plus 5 minus 3 square is 9. So x square minus 4. Okay. 3 square is 9, yes. Limit x negative 2, x plus 2. Wait. Oh, okay. Wallah, I was scared like sometimes this screen will go black like this. You won't be able to see anything, right? Like this, you won't be able to see anything. But like this, you'll see. So, luckily I got lucky. So, x plus 2 times the conjugate, x squared plus 5 plus 3 over x squared minus 4. Let's factor it already and cancel x plus 2. Now you should be able to plug in the negative 2 with no issues. Negative 2 square plus 5 plus 3, negative 2, negative 2, negative 4. bad at math, wallah. Negative 3 over 2. Yep. Yeah. Factor. Or no. 3 minus positive infinity, negative infinity. Positive, negative infinity. Or does not exist. Or just like maybe the denominator wouldn't give you 0. Let's try to plug in the number. 3 minus 4. 4 square minus 2. 4 minus 8. 4 square minus 8 minus 8. Yeah, 0. So negative 1 over 0. Okay. Now we should check from the left and the right. So limit as x approaches to 4 from the right. 3 minus x over x squared minus 2x minus 8. And from the left, 3 minus x, x squared minus 2x minus 8. So we know that the numerator is equal to negative 1, but for the denominator, like we're approaching 4 from the right. So it's 4.01, let's say. So x squared minus 2x minus 8 calc 4.01, let's say. It gave me a positive number. I don't care about the value, just a positive number. So negative 1 over positive is negative. And since it's like either infinity or negative infinity, so we have negative here, so it's negative infinity. And 4 from the left, same thing. Negative 1 from the 4 from the left, 3.99. Negative number, so negative 1 over negative, the negative will cancel, so positive infinity, I would say. So positive infinity, negative infinity. Let me check before, like, yeah, yep. So from the left, it give me positive infinity, and from the right it gave me negative infinity. So these are not equal, so that's why the limit does not exist. Okay, it says here positive infinity, negative infinity. Positive infinity when 4 from the left, negative infinity 4 from the right. Limit from the right doesn't equal the limit from the left, so it does not exist. Next. Oh, some people will say 6 over 8, but it's not acceptable in the test. Or you will get like only the mark for the answer. But you have to justify your answer, okay? So if you go ahead and plug in 0, you'll get 0 over 0. So 0 sine 6x over sine 8x. I'll multiply the top and bottom by 1 over x and 1 over x. So that would get sine 6x over x sine 8x over x. Now I will change the division into multiplication. You know how to do this, right? A over b over c over d. If you want to change it into multiplication, leave the top fraction as it is and multiply by the reciprocal or the inverse of the bottom, so d over c. 6x. Now for this, let's multiply by 6 over 6, and this 8 over 8. So I'll get limit x 0, 6 sine 6x over 6x times 8x over 8 sine 8x. So sine 6x over 6x is 1, and we have a 6 here. So 6 times 1 times 8x over sine 8x is 1, and we have an 8 in the bottom, on the bottom. So 1 over 8 times 1. So we have 6 over 8, and divide by 2, it's 2 over, no, wait, 1 over 3. 1 over 2, oh wow, 6 over 8, 3 over 4. 3 over 4, yeah, divide by 2, divide by 2, okay. 3 over 4. Yep, 3 over 4. See, he multiplied by 1 over x, and then multiplied by 6 over 6, 8 over 8. 6 over 8 times, yeah, he did the same thing, the same thing as I did. B. If you go ahead and plug in 0 over 0, خلاص. Now multiply by the conjugate, 1 plus cosine x, 1 plus cosine x, limit as x approaches to 0, x sine x times 1 plus cosine x over 1 minus cosine square x. This, you can change it into sine square x. Remember the Pythagorean identity that says sine square x plus cosine square is equal to 1. Now move the cosine to the other side, so I get sine square x equal 1 minus cosine square x. Okay, so 1 minus cosine square x is the same as sine square x. So I'm going to change 1 minus cosine square x into sine square x. So x sine x over sine squared x, 1 plus cosine x. Now we have 1 sine on the numerator and 2 sine in the denominator, so I'm gonna only remove 1 from the denominator, so only sine x, so only 1 sine x left on the denominator. Okay, now x 0, x over sine x times 1 plus cosine x. This will give me 1 times 1 plus cosine 0, which is 1 plus 1 is equal to 2. Yep. If you go ahead and plug in 0, you'll get 1 over 0. So it's either positive infinity and negative infinity. It can't be does not exist because it's a one-sided limit. If it's not, then there's a probability that it would be does not exist. But for this question, it's either positive infinity or negative infinity. Okay. Now we have an absolute value function, so we need to rewrite it as, remember how we can rewrite it. We just multiply by the same sign of the x, so 2 minus x, then flip the sign for the bottom function. Now for the upper function, it's when x is less than whatever value makes this equal to 0. So 2 minus 2, 2 will equal to 0, will equal this function to 0. So when x is less than 0 and when x is greater than or equal to 0. Okay. I already explained how to rewrite it, so I'm not gonna re-explain it again. Okay. So as x approaches to 2 from the right. Oh, sorry. Wait. It's not 0. 2. Sorry. I told you والله من الصبح ما أكلت شيء فعشان هيك مفهي. X greater than 2. Okay. So x approaches 2 from the right. So let's draw the number line. This is 2 and we're approaching from the right, like values of 3, 4, all of these values are greater than 2, so we'll go with the bottom function. So I'm gonna substitute instead of the absolute function, I'm gonna substitute instead of it by 2 minus x. Then I'm gonna substitute the 2 from the right, 1 over 2 minus 2 from the right. 2 from the right means like 2.01 or 3 or 4 or like 1000. So if you like subtract a larger number from 2, you'll get a negative in the denominator, right? You'll get a negative number. Okay, negative c, let's call it. So we know that it's negative and it's either positive infinity or negative infinity, so it's negative infinity. Okay. So, whoa, what? Wait, what? How it's x greater than 0? It's not, what? Bruh, bruh, bruh. 2 minus x, yeah. X is greater than 0, we'll use the function with the positive slope. So 2 minus x, no. Bro, this instructor needs to learn like how to rewrite this thing. Or maybe he didn't eat something in the morning like me. So he rewrite it as this, which is wrong. I'm sorry, but it's wrong. Yeah. It should be like this. But for the final answer, I don't know. Maybe he's right. Let's see. Maybe he's right. 2 minus x. Wait, x greater than, yep. Calc 2.001. Yeah, it's positive infinity, not negative infinity. When x is greater than 2, 2 minus x, 2 minus negative number. And x is greater than 2, 2 minus x. Negative 2 minus x. Oh, wait. I'm sorry, this one is flipped. this one should be x greater than 2 and x less than 2. Like this. X is greater than 2 or negative, yep, 2 minus x, and x less than 2, 2 minus x. الله يسامحك يا دكتور عماد. والله هو حكى لي انه like x minus a اكبر من يساوي صفر، فتلخبطت صراحة. بس الله يسامحك دكتور عماد. This one is the correct. انا والله انا بعرف اصلا من صف اول كنت بعرف انه هيك لازم تكون، بس ما بعرف يعني بعد lecture ما بعرف اي lecture، يمكن second lecture لما حكى لنا عن هاي ما بعرف شو صار، فانا قلت خليني اتبع خطوات دكتور عماد. بس I mean yeah, that's why I got it wrong. But this instructor is definitely wrong, because this one should be 2. This one should be 2, not 0. So he's wrong also. But maybe like he haven't slept the night before, or yeah, whatever. So when x is greater than 2, we'll choose 1 over negative 2 minus x. So 1 over negative 2 minus 2 from the right. So 1 over negative of negative number. Negative of negative number. So negative, negative, positive. So 1 over a number which is positive infinity. Okay? That's how you solve it. Okay. So just for the people who got confused, I'll teach you how to rewrite absolute values. Okay. If we have x minus 2, the sign of the x is positive, right? So we have to multiply this with positive. So x minus 2 multiplied by positive. Okay, and for the bottom one, we have to flip the sign and multiply by negative. Okay, so x minus 2 multiplied by negative. Now for the domain, equal this to 0. X minus 2 equals 0. So x is equal to 2. Okay, so this one is x greater than or equal to 2, and this one is x less than 2. Okay, now if you have 2 minus x, as in our example, you would rewrite this as the sign of x is negative, so you will multiply by negative 2 minus x, and flip the sign and multiply by 2 minus x. Now for the domain, equal this to 0, so 2 minus x is equal to 0, x is equal to 2, so x is greater than or equal to 2, and x is less than 2. It's always like this, x greater than, x less than. Okay, so yeah, that's basically it. If you have the regular x, it's simple. Positive x, negative x, when x is greater than or equal to 0, and when x is less than 0. Okay. Next question. Use squeeze theorem, easy. It's harder than the one before, but it should be easy. No, like it's the same. Wallah, it's the same. Well, no, wait. 1 over q. Yeah, it's the same. So we need to look for a function that we can squeeze it between two values. So like the sign function, we can squeeze it between what? Between 1 and -1. Now we have to make the middle function look similar to the limit problem. So we have x square like missing. So we need to multiply all of this by x squared, so we have it back. X squared. Now distribute the x squared. Negative x squared greater than x squared sine 50 pi cube root of x squared. Now we have the limit missing, so take the limits of 3 functions. 0, negative x squared, limit x 0, x squared sine 50, this is 50, pi cube root of x, limit 0, x squared. So if you evaluate this limit, you'll get negative 0 square, which is 0. And limit x 0, x squared sine 50 pi over cube root x 0. So if you evaluate this limit also, you get 0. So this limit is between 0 and 0. So you have to write this by using the squeeze theorem. Limit as x approaches to 0, x squared sine 50 pi over cube root of x is equal to 0. Okay, you have to write this at the end. Let's see his answer. Yeah, 0 by using the squeeze theorem. So yeah. Intermediate value theorem, we haven't took it yet. Skip it. Okay. Determine all values of m and k. Easy. Such that f of x is continuous. So as I told you, if f of x is continuous, so limit as x approaches to a from the left of f of x equal limit as x approaches to a from the right of f of x equal f of a. So basically we can equal all of them with each other. So let's equal stuff. X2 from the right, sorry, from the right. Wait, is it? Yeah. From the right of f of x squared plus 5 equal limit as x approaches to 2 from the left of m. Let's distribute the m real quick. Mx plus m plus k. So substitute 2. So I get 4 plus 5 equal, substitute 2, 2m plus m plus k, 9 equal 3m plus k. So k is equal to 9 minus 3m. So we got the value, or we got an equation for k, which is 9 minus 3m. Now let's equal limit as x approaches to -1 from the left of 2x cubed plus x plus 7 equal limit as x approaches to -1 from the right of mx plus m plus k. Now we can substitute instead of k, we can substitute 9 minus 3m. So I'm gonna do this right away. Sorry, plus 9 minus 3m. Now substitute the negative 1. So 2 times negative 1 cube plus negative 1 plus 7 equal negative m plus 9 minus 3m. So negative 2 plus negative 1 plus 7 equal negative m plus m will cancel. 9 minus 3m. So negative 2, negative 1, negative 3, negative 3 plus 7 equal 9 minus 3m. Negative 3 plus 7 is 4 equal 9 minus 3m plus 9. So 9 plus is 9 plus, oh no, 4 minus 9, negative 5. Negative 5 equal negative 3m. Divide by 3, so m is equal to 5 over 3. Now to find k, just plug in m, 5 over 3, 3, so k is equal to 9 minus 5, which is 4. So k is equal to 4, and m is equal to 5 over 3. Let's check. Yeah, m is equal to 5 over 3, and k should equal to, where's k? Yeah, k is equal to 4, and m is equal to 5 over 3. Okay, next question. Limit as x approaches to infinity. Take x squared as a common factor, so you get 5 minus 4 over x. X squared, 2 plus 3 over x squared. Now as x approaches to infinity, all of the constants that are divided by an x or x squared or x raised to any power will equal to 0. So these guys will equal to 0. And limit x approaches to infinity. Oh, and these will cancel. X squared over x squared is equal to 1. So yeah, 5 over 2. And whenever you have a limit of a constant, it's simply the constant. So 5 over 2. Yep. Next. Limit as x approaches to negative infinity. Take the x squared as a common factor. You will have 5 minus 2 over x squared, x plus 3. Then you can split this into two radicals. So radical x squared times radical 5 minus, and I said any constant divided by x raised to any power will go to 0. So 5 minus 0, x plus 3. This one we can simplify it to absolute of x times radical 5, x plus 3. Now the absolute of x, we can rewrite it as positive x, negative x, positive x when x is greater than or equal to 0, and negative x when x is less than 0. Now in this case, x approaches negative infinity, which is less than 0, so we're going with the bottom one. Limit as x approaches to negative infinity. Instead of the absolute value, I'll substitute negative x times root 5, x plus 3. Now, from the denominator, I could take x as a common factor. Limit x negative infinity. Negative x times tuck. I'll take x as a common factor, so I have 1 plus 3 over x. This will go to 0, 3 over x, as x approaches to infinity. So I'll continue here. Limit as x approaches to negative infinity. Negative x root 5 over x. X's will cancel. So limit as x approaches to negative infinity of negative 5. And whenever you have a limit of a constant, it's simply the constant. That's how I solve it. Yes. Oh, this one can be solved by L'Hopital's rule, but let's see. Oh, we could take, yeah, okay, we can solve it algebraically. It's easy. Limit as x approaches to infinity. 4x over 7 to x. We can take the ln of the numerator and the denominator, I guess. Yeah, I guess. I'm guessing صراحة. Equal limits x infinity. Now, from properties of logarithms, when you have a power, you can drop it before the logarithm. So I can rewrite this. Sorry, I can rewrite this as x ln 4, and this one I can rewrite it as x ln 7. X will cancel, so I have limit x infinity of ln 4 over ln 7. Ln 4 over ln 7, this is a number, this is a number, so this whole thing is a number, and we have a limit here, so whenever we take a limit to a constant, it's just simply the constant. Ln 4 over ln 7. I think so. Okay, we جبنا العيد. It's not ln 7 over ln رافشو. Let's see, 4. Oh, okay. والله انه ذكي. والله he's smart. He's smart. So basically he said 4x over 7x, like we can take the exponents and raise it to the whole fraction. Like whenever, like maybe you have let's say x square over y square, you can rewrite it as x over y and raise the whole fraction to square. Okay, same thing here, except it's not a square, it's an x. So basically you can apply the same rule. So he said limit, forget about the ln, it's totally wrong. Limit as x approaches to infinity of 4 over 7 and take the x for the whole fraction. Now substitute infinity into this. So 4 over 7 to infinity. When you have like number raised to infinity, no, wait, sorry. No. Oh, not 1. Any number else. any number less than 1. Less than 1. Less than 1 and greater than. Since since 4 over 7 is a fraction, like it's less than 1. When it's 7 over 7, it's equal to 1, but it's less than 1 because it's 4 over 7. So when you raise like a fraction, when you raise a fraction to a very large number, it goes to 0. That's what I understood from his notes, yes? But if you raise like 7 over 7, it's 1. If you raise 8 over 7, which is above 1, you get a math error or an infinity. If you raise 6 over 7, you will get 0. So since 4 over 7 between -1 and 1, anything that lies between -1 and 1, and if you raise it to a very, very large number, you will get 0. So that's how we solve this question. This one is between -1 and 1. So I'll write it here. Any time you have a fraction that is raised to a very large number, then it goes to 0. Oh yeah, it equals to 0. So we have a fraction raised to a large number, so it's equal to 0. That's how I solve the question. Next, oh sheesh, next one. Same question, but instead of infinity, it approaches negative infinity. I guess it's the same. Well, a very large number, but a negative. So I guess it's the same. I guess I won't solve it, but I will see. Oh, it's not the same. 4x, yeah, he did the same. He took x for the whole fraction. Now 4 over 7 to the power of... Oh, okay. Yeah, okay. He did the same. Took the x for the whole fraction and then substituted the negative infinity. Now it's a negative power, so in order to make it a positive power, you have to like flip it, or not flip it, like take the inverse, or I don't know what it's called, but like this, okay? So in order to make this power a positive power, put it in the denominator, so it will turn to positive. So a fraction raised to a very large number will give you 0, right? So 1 over 0. So 1 over 0 will give you positive infinity or negative infinity, or does not exist. Okay, so oh, he said, I mean, just skip this question because it has a great idea of like turning the negative exponent into a positive exponent, and then this value becomes 0 from the right. I don't know how he got this 0 from the right, like why it's not 0 from the left, or 0 in general. So that's why I'm telling you skip this question, because yeah. if you encounter this question tomorrow, the answer is positive infinity. Okay. No. B finish. Oh. Find the domain and range of each of the following functions. Oh sheesh, I'm not gonna find these. I'm not gonna find these والله ما لي دخل. والدومين مين يا عمي؟ not gonna find these والله. Let's skip C because like not sure. I'll give you the idea of each question just in case. This one is like squeeze theorem. We already solved many questions about it. You have to squeeze one of these functions, like either the x to the power 4 or the trig function cosine 2 over x. You have to squeeze one of them between two values. X to the power of 4, you can't squeeze it or like putting it or restrict it between two values, but the cosine function you could do that. You could restrict it between -1 and 1, and then multiply by x to the power of 4 and take the limit. You'll get 0 from left and right. This one, multiply by the conjugate. The conjugate would be times. Okay, let's solve this one. Let's solve this one. It's good. I'll solve it without like explaining because it's self-explanatory. Wait, والله لازم أشيك عليها.
Self-explanatory.
Self-explanatory. Okay. 1 plus cosine plus cosine. Okay. Limit x 0. 1 minus cosine square x square. 1 plus cosine x. This would give me sine square x square 1 plus cosine x. So this is 1 times 1 over 1 plus 1, which is 1 over 2. So the answer will be 1 over 2. Let's check it. F. Yeah, he multiplied by the conjugate. 1 plus cosine x. He got 1 over 2, yes. Next one. If you go ahead and plug in 2, you get 0 over 0. So let's factor the numerator. Tuck. 1, negative 6. X minus 2. X plus 3. X minus 2 and x plus 3. X minus 2. Don't forget the limit, but I'm writing like in a fast way, so I skipped it. X minus 2. It's positive x minus 2 and negative x minus 2 when x is greater than or equal to 2 and x is less than 2. So in this case, x minus 2, and as x goes to 2 from the right and as x goes to 2 from the left, we'll use negative x minus 2. So x minus 2, x plus 3, tuck, x plus 3 with the negative outside, and here x plus 3 without a negative. Now plug in 2, 2 plus 3 is 5, and here negative 5. So it does not exist. 5 and negative 5 does not exist. Yep, does not exist. has 5 and negative 5, so it does not exist. Bado. Conjugates. Bruh. Like, the conjugates, anyone can do that. Multiply by x squared plus 25 plus 5. Yeah, I will give you a tip when writing radicals. If you don't know how, or like, maybe I'm writing x squared plus 5 and I'm writing radical like this plus 8x plus 3. So you keep like extending it. So instead of doing this, I see like people do this for a radical. I don't like this. I put like this. It's better for me. Anyways, just write this and write your thing plus 6 blah 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 blah, and when you finish, just like draw a line until you cover all of these. That's the correct way of writing a radical, or the optimal way of writing a radical. Okay, just a quick tip here. Limit, I don't do it anyways, like I don't have to. I can estimate 25 tuck tuck, x square will tuck tuck, so x square plus 5 plus 5, so 1 over radical 5 plus 5, so radical 5 plus 5, yeah, it's 1 over radical 5 over 5, 1 over 5 plus 5. Oh, plus 25. Sorry, plus 25. There is a 2 here. This explains a lot. 5 plus 5, which is 1 over 10. Yep. Okay, this one. As I told you, you can't say 2 over 1. You have to justify your answer. Multiply 2, 2. Limit x 0 to sine 2x over 2. Oh, wait. Sorry. Multiply by... First multiply by 1 over x over 1 over x. So I get limit as x approaches to 0 of sine 2x over x. Here sine x over x. Now convert the division to multiplication. I showed you how. Keep the top fraction as it is and flip the bottom. This one has a 2 here. So multiply 2 over 2. You should get limit x 0 to sine 2x over 2x times x over sine x. This one will give you 2 times 1 times 1, which is 2. Yep, 2. You should factor the numerator. So a cube minus b cube, a minus, oh sorry, plus b, a square plus, swap switch the sign or flip the sign. AB plus B square. So x plus 1 x square minus x plus 1 over x square, x plus 1, x plus 1 will cancel. Tuck tuck. So, okay. X negative 1, x square minus x plus 1 over x square. So negative 1 square minus negative 1 plus 1 over square. So 1 minus 1, so 1 plus 1 plus 1 over 1, 3. Yeah, 3. Factor the denominator. Limits as x approaches to 3. X minus 3. 1 to 8. 15. X minus 5. X minus 3. X minus 5. X minus 3. We can cancel. Tuck tuck. Limit x3. Substitute 3 minus 5 over negative 2. So negative root 3 over 2. Where is it? Yeah, negative root 3 over 2. Skip the graph. Skip. 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 Okay. C done. CD. Oh, sheesh. I'm not doing this, bruh. Oh my god. Compute the following limits. Justify your answer. Holy. Oh my god. Oh, it's only one page. Okay, I'm doing it. I thought like 5 with 6 pages. If it's one page, okay, nice. This was a quiz. 15 minutes. Professor Waldo. Oh, he has PhD. MashaAllah. He has PhD and he's known on Google. Nice. Nice. Wallah, akhi, I love math nerds. Wallah, you're the best, man. You're the best. Nice. German has been. Oh, sheesh. He has his own website too. I'm assistant professor of mathematics and mathematics. Oh, so he used to teach at KU, I guess. Cause yeah, he used to teach at KU. He has a PhD. Dang, man. I mean, all professors, not all. Only one connection, bro. Verify now, please, man. Verify me. Verify me, bro. Oh, notification. Uh, 14 impressions. Yeah, follow me, guys. Just type Majduddin Sukkari on LinkedIn and follow me. Or they call it Connect, I guess. Shamsa, what? What? Oh, Majduddin, you're not verified. Get 60 views. Man, I can't get verified. How these guys got verified? Khalifa University verified association using email. I mean, I'm using my KU email and I haven't got verified yet. I don't know why. But yeah. See my certs. I have this. Yeah. 46 impressions. I mean, impressions means views, aka views. 60 views, 40 views, 32, 15. Yeah. This one has the most views. 60 views. Sheesh. Okay. Okay. Back to math stuff. I mean, well, this professor, how do I contact him? Is he still alive? See, complex analysis. He has a profile on Google Scholar. Cited by he's doing researches. I mean, bruh. Oh my god. Research paper. This guy knows Chinese. What's this like? Russian? Mashallah, mashallah. يا لهوي يا لهوي والله math nerdies bruh. This is the math that I'm talking about. Not like limits. Limits, like, I can solve them with my eyes, wallah. This is what I'm talking about, guys. يا أخي إبداع والله إبداع إبداع. Even though I don't understand anything from here. Okay, integration of this called phi. Phi. But it has like two forms. A phi with this, which called the golden number. Someone called it golden number. 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 Yeah, golden number. Formula is equal to 1 plus root 5 over 2. So it has like two meanings. The phi is like phi, like no solution, and it has like a number. So in this case, I think he's referring to this 1 plus root 5 over 2. So this is called the golden number. Or the golden ratio. Same thing. The golden ratio. So yeah. I love math stuff. I'm a math nerd. Not like this guy, or sorry, not like this professor, but I'll be one, inshallah. But not like him. He's like super, super nerd. Okay. Um. Okay, for this question, we have to multiply by the conjugate. Limits x positive infinity, x plus root x minus root x multiply by x plus root x plus x minus root x, x plus root x plus root x. Okay, so for the numerator, we can simplify as a square minus b square. Where is a, where is b? This is a, this is b. So x plus root x square minus x minus root x square. So the square will get rid of the radical minus. Put them in parentheses, please. X minus root x. Now x plus, distribute the negative, minus x plus root x, x minus x to radical x. So the numerator is just simply 2 radical x, and the denominator, don't touch it, leave it as it is. Limit as x approaches to positive infinity, 2 radical x, and here x plus root x plus x plus root x. Now if you think about it, root x you get like positive infinity, and infinity plus infinity plus infinity. Oh, you get also infinity. Oh sheesh. I think you'd also need to multiply by the conjugate again. I think. But that would be useless. Wallah. Let's try. Man, I'm pretty sure it would be useless. Let's try. Trying will never hurt. Okay. Limits x plus to infinity. 2 radical x plus x minus. So x plus root x minus x plus root x. So x plus root x minus root x. So x minus x and root x minus root x. Bruh, you'll get a 0 in the denominator. You can't get that. You can multiply by the conjugate. Let's see how he solved it. Well, you get infinity over infinity. Let's see, wallah. Yeah, I did the same, notice. Oh, okay. Okay. Oh, I don't understand how. Oh, actually, I don't understand. He took what? Oh, Now, wallah, this guy's so smart. So smart. Smarter than me. Limit as x approaches to positive infinity. Or maybe like I'm sleepy, I didn't eat anything, and I'm solving. Like, excuse me? He took basically what he did, he took x as a common factor. He took x as a common factor. So 1 plus um root no it's 1 over root x. 1 over root x, yeah. So x, yeah. 1 over root x. So basically he took x as a common factor. And he's left with 1 plus 1 over root x plus x plus, no, he did the same thing. 1 plus 1 over, there's something wrong with this. Yeah, one of them should be minus. Yeah, minus. Okay. Now he took 2, tuck, tuck. He took tuck, tuck times tuck, tuck. As x approaches to infinity, this one becomes 0. So 1 plus 0 plus tuck, tuck. This is also becomes 0. 1 minus 0. So he took 2 tuck, tuck. He took root x as a common factor. And 1 plus 1, because root 1 plus root 1. And I already took root x as a common factor, so the root will cancel. So 2 over 2 is equal to 1. Yep, 2 over 2 is equal to 1. Wallah, this guy's so smart. So smart. I'm gonna give you this exact same question in the group. If someone solved it without watching this video, he's so smart also. Or like, he's not so smart. Like, all of all he did is like taking x as a common factor. I could have thought about this, but I mean, I told you I'm sleepy. Yeah, I'm not gonna give excuses. Suppose curve also allows you to then, oh, suppose y equal f of x is the function of a curve which always lies between the curves. Then oh, we should take the limit. Oh, this basically the Squiz theorem, application of a Squiz theorem. So basically, he's saying that f of x lies between these two functions. F of x lies between oh wait, yeah, y equal, okay, nice. So x squared plus 1, x squared plus 1, yeah, and y as a common factor, yx plus y minus 1 equals 0. والدال الطرف الثاني yx plus y equal 1, yx plus 1 equal 1. So y equal 1 over x plus 1, yeah. X plus 1, y over x plus 1, y 1 over x plus 1. Now take the limit as x approaches to 0 for all of them. So 1 over 0 plus 1 this will give you 1 limit as x approaches to 0 f of x. Now 0 square plus 1 will give you 1. So by using the squeeze theorem, limit as x approaches to 0 of f of x equal 1, sorry, equal 1. Yep. Equal 1 as x approaches to 0, hence by squeeze theorem. Okay. The equation x to the power of 4 has a solution in the open interval where n is the positive. Okay, what's the question? To find the n? Find the n. I think he's asking for n. I mean, it's not like let f of x. It's easy to see. Oh, find m. Where's m? What m, bro? Oh, this is an n? Bruh. So m is equal to 3. Okay. Let f of x, it's easy to see. Oh, okay. He took like 3 and 4. I could take 5 and 6. Any consecutive numbers, like 5 and 6, 6 and 7, and solve it, you will see that n is equal to 3. المهم doesn't matter. So D done. Dr. Ilyas, I mean, we don't have to do them. We have only Dr. Ahmad. We solved his quiz already. Answer key quiz. What is this? Quiz YE. Oh, let's see. Question 1. So let's define the absolute x when x is greater than or equal to 0 and x is less than 0. Now he's asking in general, so we have to check on both from the positive side and negative side, yani from the right and left. Sine x over x. Now from the right we'll use x, and from the left we'll use negative x. So limit as x approaches to 0 from the right, sine. From the right I'll use x, and from the left I'm going to use negative x. So this is just simply 1. And this, remember, sine of negative a is equal to negative sine of a. So basically I could pull the negative out of the angle. So limit as x approaches to 0 from the left, negative sine x over x. Sine x over x is equal to 1, but we have a negative, so it's equal to negative 1. So they don't equal each other, so does not exist. As side limits does not equal, limit doesn't exist, okay? So it's just easy. Complete the square and explain how to transform the graph into skip, factor, skip. Okay, skip. Move quiz 1F. Let's just take a brief look at it. Okay. -2, -2. Okay, does not exist. 5 from the left, 5 from the left, negative infinity. -8. This is -1, -2, -3, 4, 5, 6, 7, 8. Undefined. Does not exist, and he considered it as correct. He should write undefined. There is a difference between undefined and does not exist, man. Derivative. We didn't take derivative yet, bruh. Yeah, this one is not quiz one. Definitely not quiz one. I mean, maybe it's quiz one, but he's combining quiz one and quiz two together. Okay. F0, 0, -6, 1, 2, 3, 4, 5, 6. It's not differentiable, so I'd say it does not exist. Yeah. F -7 is this -7. It's negative something, because it's a negative slope, but negative what? I don't know. -1/2? I don't know, man. But it's negative something because it has a negative slope. List x values is but not differentiable. Oh, -6. Yeah, only -6. Only -6. Bruh, 3/2, 0. Oh my god, man. This guy's cooked. Explain the reason which from the left at what? Is continuous from the left as -2? Because it's continuous? Explain reasons for which f is continuous from left. Because limit as x approaches okay, nice. List intervals where the derivative is negative. -8 to -6. -2 to -1.5. 0 to 1.5. 3 to 5. Yeah. And 5 to 10. 5 to 10. 1.4? Man. 1.5. It should be 1.5, wouldn't it? I mean, it's okay, no. It doesn't matter, صراحة. Okay. Simplified it using limit definition. We know how to do this. Oh, we have some limits here. Okay, x -7 over 7 minus x. Let's solve this one. This looks promising. With equality especially. 7 minus x plus, oh no, sorry. 7 minus x plus 7 minus x. This one when x is greater than or equals 7, and this one when x is less than 7. Okay, so we're approaching 7 from the left. So I'm going with 7 from the left, the positive one, 7 minus x. So yeah, -1. Bruh, -1. Bruh. والله I'm فنان أقسم بالله. والله I'm فنان أقسم بالله. Yep. check with the calculator. It should equal -1. X minus 7 over 7 minus x calc squared 9. Yeah, -1. We do have something like do tomorrow or something? Because if so, I'm cooked. Wait, where is the exam gone? Oh, till 8th February. Okay. So tomorrow's the quiz. Then, oh, sheesh. Exploring GC class wiki. Oh my god. This one. This one you have to check from left to right. I mean, let's solve it. Let's solve it. It's easy. If you go ahead and substitute, you'll get -10 over 0. So, limit as x approaches -5 from the left, 2x over 5 plus x, and limit as x approaches to -5 from the right, 2x 5 plus x. So -10 over -5 from the left, so it's a positive number, so -infinity. Right? -5 from the left, like -5 from the left, 5 5 plus -5.1. Let's see. Oh, so it's a negative number. Negative number. مش positive number. So negative, so positive infinity. وهذا -10 over -4.9. This one is a positive number. It's positive, so -infinity. So positive infinity, -infinity. From left, it's positive infinity, and from right, it's -infinity. In conclusion, does not exist. Okay, nice. 4 over x. Yeah. 1 over cosine. Wait, what? 0 from the... Wait. 0 from the left. 4 over x. 0 from the left is -infinity. This 0 from the left is 1. So 1 times the... Oh, okay. 1 times -infinity. Okay, makes sense. Okay. Use the derivative rules. We haven't took derivatives yet. Find the values of c. Oh my god, the quality is hurting my eyes, wallah. Limit as x approaches to pi over 4 from the left, cx plus sine square x equal x pi over substitute pi over 4, pi over 4c plus, your calculator should be on radian mode, so sine pi over pi, oh, pi over 4 half, and for the cosine also half. I mean, yeah, it should be half because of the Pythagorean identity. Pi over 4 minus half c. So pi over 4c plus 1 half c equal pi over 4 minus 1 over 2 pi over 4 plus 1 over 2. Oh, sheesh. So maybe I'll get c as a common factor. Pi over 4 plus 1 half equal pi over 4. This minus 2. Then divide it by pi over 4 plus half. Okay, and we should get the value of c then. Zero point 222. 0.222. What? C equal 1? Nah. C equal 1. There's no way. Pi over... What? Yeah, he got it wrong. Like he was credited on the steps, but I got it wrong. There's no way it's C. C is equal to 1. No way. Let me check. 0.67. طيب. 0.67, 0.67, 0.67, 0.67, 0.67, 0.67, 0.67, 0.67, 0.67, 0.67, 0.67. Yeah, 0.67. So it correct answer is 0.222. Okay. If H that okay. Skip. Okay, nice. Quiz G. Okay, let's go through it. -3. -3 is -2, correct. 2 from the right. 2 from the right is 2. 4 from the 4 from the left. Close to infinity. Okay, this is wrong. Close to infinity and just stay. Bruh. Whites does not exist. 4 does not exist. A, B, C, D, E. 6 from the left. 6 from the left. 6 from the left. -2. -7, 4. -3. Yeah, undefined. Stated domain.
-7 close bracket till -3 open bracket, union -3 to -3 open bracket to 2 no لا ثواني -7 to -3 open bracket, then from -3 to 4 open brackets, then from 4 to 6. -7 to 3, -3 to 4. Correct. And from 4 to 6, nice. Stay the removable. Removable, I mean, -7, -3, -7, -3 الباقي كله من removable. Ah man. -7 is also removable, no? Removable 2 and 4. Correct. But you have to add -7. It's removable. True or false, f continuous to the right. -7 to the right. Nope. F continuous to the left. X equals 6. Yeah. True. Use algebraic. Oh, sheesh. I mean, I'm asleep, man. والله خلاص we revised like several times. Okay. Plus I'm not going to continue. Hope you find this live session helpful. I mean, the viewers like I think zero, maybe like a chance of 3% that there is one watching, but I guess it's zero because it's too late and no one cares. Like the questions are got leaked, and yeah. But if there's a viewer, study hard. Um, don't don't like don't rely on the leaked questions, because I mean, solve it in a legitimate way and an ethical way, so Allah like will يجازيك. ما بعرف كيف احكي يجازيك، بس انه راح يجازيك على فعلك الجميل ان شاء الله. السلام عليكم.